So these look particularly annoying, but they actually have an easy solution because they're all set to equal 0, which means when we multiply the left side of any equation where the right side is equal to 0, for instance, if we were to multiply this left side, put it in brackets, by 5, and you multiply the right side by 5, 5 times 0 still ends up being 0. Which means to change any fraction in a solution like this, you look at the small and the big and you say, okay, the one that's in common to both is 25 because 5 can go into 25. So if I multiply the left side by 25 and the right side gets multiplied by 25, it simply becomes 0. 25 times k squared is 25k squared. 25 times 4, but divided by 5 becomes 5 goes into 25 5 times, so it becomes 5 times negative 4, negative 20. Okay. And then finally, this 25 and the last one will cancel out. You just have plus 4. And the right side stays 0. If I look very carefully, this has a square root, and this has a square root. This square root is 5, okay? And because this middle term is minus, we would say minus 2, and we would see if that is a perfect square. 5k times, so if I do this, minus 20, or positive 25k squared, minus 10k, minus 10k, plus 4. So that factors out perfectly to that. Always when you have something like this, where each number at the first and the last can be square rooted, check for perfect square. And in this case, yeah, the middle term would come out as minus 20k, but only when this is minus and minus. Therefore, the quadratic equation for this is this. Now, if they were to ask us where the roots are, oh yeah, now we got to solve for k, right? So it's equal to 0. For k in its simplest form, yeah, okay. So now when we solve for k, our first step is to square root both sides, but a square root of 0 on the right rather, is 0. Then we add 2 to both sides. Then we divide by 5 on both sides. K is equal to 2 over 5. Now, if I were to put that in here and solve, we will get 0. So let's try it out. 2 over 5 apparently is the solution. What's 2 over 5 in this k value here? Squared is 4 over 25. 2 over 5 here, so minus 4 times 2 over 5 is minus 8 over 25. And this one doesn't have a k, plus 4 over 25. We can see 4 over 25 plus 4 over 25 is 8 over 25. 8 over 25 minus 8 over 25 is 0. So the answer for this is k is equal to 2 over 5. They're all going to be solved like that. So if I look at this one, doesn't matter if it's a w, it's equal to 0. They want me to solve for w, and I look, the 36 is divisible by 3, so I multiply both the right side and the left side by 36. I get 36w squared. 3 goes into 36 12 times, and 12 times 5 is plus 60w. And of course, 36 times this one that cancels with the bottom, I get plus 25. Again, I see a perfect square root. This one is 6w. This one is plus 5 because the middle term is plus. Let's see if I were to multiply these things out, if I would get the thing here. 6w times 6w is 36w squared, plus 5 times plus 5 is 25. What about the middle term? 6w times 5 is plus 30w, plus 30w makes plus 60w. Therefore, this is the perfect square. Like this, we're going to set it to 0. Square root both sides. Well, square root of 0 is just 0. Subtract 5. Divide by 6. W is make negative 5 over 6. Now you can always test it out and put it in there to see if that's what you get. I'm not going to bother. Yeah, but when you do test out, the left side should come out as 0. Okay, and you just substitute it in and add all your fractions. Solve for k in the simplest form. It's very similar to the one they just gave us. I think he made a mistake. That's the same answer. So number 3, he accidentally gave you the same answer. But this time it's with, if you look closely, it's with k. Well, that's the same equation. So the answer for that one will be the same. So this here, it's just k will be equal to it. I think he just messed that up. If you look here, the common term is 25. Oh, this looks similar to the last one. Well, very similar, but not quite. So the common term is 25. If I multiply left side by 25, I get 25x squared. 5 goes into 25. 5 times minus 6 is minus 30. And the last one stays 9. Again, I can see a square root in the beginning is 5x. I can see the middle term is minus, so minus the square root of 9 is 3. If I were to multiply these two terms, that's the middle term. This definitely becomes 25x squared, and this definitely becomes plus 9. 5x times minus 3 minus 15x. Minus 15x becomes minus 30x. So that's it there. We set it equal to 0. Square root both sides, still 0. Add 3 to both sides. Divide by 5. X is equal to 3 over 5. Okay. Over and over again, it's the same thing. I'm sure it's going to get a little bit harder as we come up. Five and 7. Just got to pull her down a bit. There we go. And try again. No, didn't quite get them all. 5 and 7 is what I'm after. There we go. Well, 5, the common term is 9. When I multiply the left side by 9, I get 9x squared minus 16x plus 4. I can see 9x squared and 4 both have a square root. 3x minus 2 because there's a minus here. And if I do it out, 3x times minus 2 is minus 6x, minus 6x. Oh, I did a little error there. So when I multiply, this should be minus 12. Yeah. Yeah. Because 9 times that, 3 goes into 9 3 times, 3 times minus 4 is minus 12. And then plus 4, and sure enough, the proper root for that is 3x minus 2 squared is equal to 0. Square root both sides. Add 2. Divide by 3. X is equal to 2 over 3. Common term here is 16. When I multiply by 16, I get 16y squared. 2 goes into 16 8 times, so 8 times 1 is 8y. And then minus 3. These do not have a square root, right? This does not have a square root, so clearly we're getting a little trickier. So we're dealing with 16. It doesn't matter if it says y squared or x squared. Plus 8y minus 3. Our first step is to use factoring. And when we factor, we're looking for numbers that multiply out to a times c. A is 16, c is 3. 16 times minus 3, rather, is minus 48. So we're looking for a number that multiplies out to minus 48, that adds up to plus 8. 48 has a factor of 4 and 12. Because this is positive and this is negative, one of them will be negative. And since this is a positive number, it will be, this one will be, the bigger number will be the positive number. Minus 4 plus 12 is plus 8, and minus 4 times 12, minus 48. Normally, so our factors are minus 4 and 12. So normally, we could just say y minus 4, y plus 12. However, we can't because there's a 16 in front, so we have to group. So what you do when you group is 16y squared stays there. minus 3 stays there. This middle plus y gets divided into the two terms we discovered, plus 12y minus 4y. Then you focus on 2 at a time. What do these two numbers and y's have in common? The answer is they're both divisible by 2. Let's see, it becomes 6 and 8. They're both divisible by 4. So if I factor a 4 and a y from them, I get 4y plus 3. Over here, I factor these terms. You might say they have nothing in common, but I don't want the first term to lead with a negative. So I factor out minus 1, and I'm left with 4y plus 3. When you do grouping, these two brackets should be the same. So if they aren't, you did something wrong. Now I can factor out that bracket from both. 4y plus 3. When I separate that bracket from both, 4y plus 3, what would be left if I factored that out? Well, we just remove it and see what was left. It's 4y minus 1. So these are the two factors equaling 0 for this equation. Sure enough, if I go out, I get that. So I did it correctly. For this to be true, either bracket has to be equal to 0. For this to be true, either bracket has to be 0. So you have to set each to 0 to solve. Four y plus 3 is equal to 0. 4y plus minus 1 is equal to 0. Subtract 3 from both sides. It goes just essentially to the other side, but a negative number. And divide by 4. Minus 3 over 4 is our first answer. This one I add 1 to both sides. And divide by 4. Y is equal to 1 over a quarter, or minus 3 over 4. If you put it way back in the original equation, both answers are valid. Oh, in this original equation over here. If your teacher ever asks you to verify, that's what it means. You have to put it back into the equation to solve. Okay, let's look at 7 and 8. Yeah, okay, 7 and 8. I just cut off the equation. There we go. So this one, the common term for both is 6. When I multiply the left side by 6, I get 6k squared. 6 goes into 6 one time, so I get plus 7k plus 1. It's clear I have to factor. I'm looking for a number that multiplies out to 6 and adds up to 7. The only one possible is 6 and 1. When this number is bigger than that number, that's the only possibility of it in quadratic. So that means normally you would have to group, but let me also show you. So do your grouping, practice your grouping. That means we get 6k squared plus 6k plus 1k. So the two factors we found, the 7k becomes whatever those two factors are, plus 1. Then you have to factor out 6k here and nothing there. So you get 6k plus. Oh yeah, so let me just show you what happens when you do that. That's 1. On the left, those two things that have in common is 6k. I'm left with k plus 1. You might say, well, I got nothing to factor out on the other side. And you're correct, but how you write it is there's essentially an invisible 1 in front of the k plus 1 that's left here. And that means this bracket is one of the factors. And when I factor it out, the only thing that remains will be this 6k plus 1, which is why you write it like that, so that you can see the second factor. There are always invisible ones in front of everything. Then I have to solve both to set to 0. I want to show you a cheat method instead of grouping. So we discovered our factors are 6 and 1. So you just go, okay, well, it's k plus 6, k plus 1. And you say, well, Peter, you told me you can't do that because of the 6 in front. You're right, I can't. So what you do is you take this 6 and you divide both these things by 6. If it is possible to divide it or simplify it, you do so. If it is not, in this case, The 6 instead slides up to there. Slip and slide. And these are my two factors, which is correct. So that's a cheat method. So anyway, now I have to set both these to equal to 0, because remember right here we have it equal to 0. That means either one can equal to 0 for this equation to be true. When I solve for this one, I get k is equal to -1. And when I solve for this one, k can also be equal to -1 over 6. Those are the two possible solutions. This one, the term in common to both the 3 and the 30 is 30. So when I multiply the left side by 30, I get 30x squared plus 13x. Minus, or 3 goes into 30 10 times -1 is -10. It's clear I can't necessarily, there's no perfect square there. So I'm looking for what's 30 times -10. I'm looking for something that multiplies out to -300 and adds up to 13. Which makes life a little hard, except when I quickly notice -30 times 10, that would add up to 20. So that's close. So maybe divide this by, or double this and half this. -15 and 20. That would add up to 5. So we're in there. So it's something between 10 and 30 and 15 and 5. $20 times 1.5 is what it would be. Yeah. No, times 15. That adds up to 5. Can't be that close together. So we have to work on our factors. So there's 30 and 10. That would not add up. 60 and 5. That's too far apart. So I have to go the other direction. 15 and 20. Too far apart. Sometimes you have to look up your factors of that. Let me just make sure I got everything right. Yeah. And if you can't come up with it, you could always use the quadratic equation, but the quadratic equation is a little harder. So let's just keep looking and see. All my factors of 30. So 301, 150 and 2, 75 and 4, and doubling this and halving that. And after that, I would divide this by 5 and multiply this by 5. 20, yeah, I already did that one. And this is 5, goes into it 10, 15 times. That doesn't work. And these are very close together, 5, and I'm trying to come up with a number that adds up to 13. So I have to find it a little further apart than that. Well, you know what? It kind of stumped me on this. So let's just look up factors of 30. Oh, factors of 300. There we go. Five and 50. No, 6 and 50. No. There it is. 12 and 25. So somehow I screwed that up. I don't know how. Because I said 12 and 25. No, hang on. We're not looking for 13, are we? Yeah, 13. 12 and 25. So the numbers that multiply out to negative 300 and add up to 13 are 12 and 25. But because 13 is positive and this is negative, this has to be positive and this has to be negative. So negative 12 and plus 25. Using slip and slide method, x minus 12, x plus 15. Is that right? That's not right. X plus 25. There we go. And then if I divide both by 30, these are both divisible by 6. It becomes minus 2 over 5. And then the 5 slides up. 5x minus 2. And these are both divisible by 30 over here. They're both divisible by 5. That becomes 5 over 6. So this becomes 6x plus 5. And let's see if that worked. 5x times 6x is 30x squared. 5x times 5 plus 25x minus 12x becomes plus 13x. And minus 2 times plus 5 minus 10. So those are the factors. And when I set them to 0, 5x minus 2 equals 0 becomes 2 over 5. And the other one becomes minus 5 over 6. So I'll let you figure out how I came up with that. It's just the opposite of that and divided by this. Grouping will work too. Practice your grouping. The 13 would become both plus 25x and minus 12x. Okay. Kind of brain farted on that one. Usually a sign that you're tired. These go on and on and on. Oh my God, he's really... Holy cow, yeah. So he's going through the solution. It doesn't really show you how to solve it, which is kind of pointless, given the solutions. I'm going to keep going and see if there's any weird ones, because I don't want to keep solving these straightforward. It's the same method. Multiply by the common factor over and over again. Okay, so these ones all the way to 14. If I multiply by 30, I get, didn't we do this one? Yeah, we did this one. So that one's done. Multiply by 6, I get 6y squared minus 7y plus 2. If I'm looking for something that multiplies up to 12 and adds up to minus 7, 4 and 3, both negative. Because this is positive and this is negative, they both have to be negative. Slip and slide, I get y minus 3, y minus 4. I divide them both by the 6. This simplifies to minus 1 over 2, so I get 2y minus 2. Is that what it is? So I'll do it again because it's all, I kind of messed that up. Minus 4, sorry, minus 3. When I divide that by 6, it becomes 1, and this becomes 2. And this one, y minus, that was 3, so this is minus 4. When I divide it by 6, it simplifies to minus 2 over 3. So that becomes 3y minus 2, which means my solutions are 1 over 2. So positive that divided by the 2, positive that divided by the 3, and 2 over 3. So y can be either one of these. And this will come out as 0. This one, the secret here is there's none if we just want to use normal factoring. So we're looking for a number that multiplies out to minus 72 and adds up to 14. So they're just kind of making you work. This is probably 12 and 6. No? 6 and 12 is a factor, but it doesn't add up. So 3 and 24, almost. Again, factors aren't clearly visible, so we'll start with normal. 72 and 1. 36 and 2. 18 and 4. Ah, there it is. 18 and 4. So since this is positive and this is negative, it's going to be positive 18 and negative 4. Practice your grouping, becomes 18, 4, yeah, and just go from there. I'm not going to do them all. It's the same method over and over again. These don't have anything in common. Sometimes you got to look and see if the numbers have something in common. You can factor them out. If it doesn't, we're looking for something that adds up to minus 450. Sorry, multiplies out to 450 and adds up to 7. Big pain in the butt. These factors are going to be close together because the 7 isn't very big. 45 and 10. No. Double this, not half this. So I'm going to divide this by 5 and multiply this by 5. So we get 9 and 50, too far apart. 9 and 50. So it's going to be a factor that's closer than 45 and 10. Not by much. So we're going to look at 150 and 3. 5 and 10. Let's see, 45 and 10. Oh, do I have to use the quadratic equation? Oh, no, we don't. 45 and 10. So again, I'll just get lazy and look up the factors of 450. And I'll be mad when I see what it is. In pairs, yeah. Should ask it to do it in pairs. And I'm looking for something that adds up to 7. There it is, 18 and 25. Stupid. 18 and 25. Since it has to add up to 7, 450, the 25 must be the positive one, and the 18 is the negative one. Slip and slide method, it would be n minus 18. When I divide it by 30, they're both divisible by 6. This becomes a 3. So now I get 5n minus 3. And the other one, n minus plus 25. When I divide by 30, they're both divisible by 5. This becomes a 6. This becomes a 5. So it's 6n plus 5. So 5n minus 3 and 6n plus 5, which means the solutions are n is equal to 3 over 5, or n is equal to minus 5. 6. Suddenly this gets much easier, which makes me suspicious. And we're looking for something that multiplies out to minus 6 and adds up to 1. So that's going to be plus 3 and minus 2. Using the slip and slide method, when I divide it by this first number, 6, these are both divisible by 3. This becomes 1. This becomes 2. So it becomes 2w plus 1. And the other one, w minus 2. When I divide by 6, they're both divisible by 2. This becomes minus 1. This one becomes 3. So it's 3w minus 1. And the solutions here are w is equal to minus a half. For this one, w is equal to 1 over 3. And this one's similar. These are much easier, actually. So you're looking for numbers that add up to positive 24. Sorry, multiply out to positive 24, a times c, and add up to 10. It's 2 and 12. 2 and 12 looks like it should work, but you can't subtract it because everything's positive. 8 and 3 does not work. 2 and 12 does not work. 6 and 4, there we go. 6 and 4. If I do slip and slide, it's n plus 6, and I divide it by 8, the front number. They're both divisible by 2. I get 3 over 4, so I get 4n plus 2. And the other one, n plus 4, when I divide it by 8, they're both divisible by 4. I get 2n plus 1. If I do it out, 4n plus 4, 4n plus 4n does not equal 10n. So let's see what I did wrong there. 6 divided by 8. This should be a 3. Yeah, this first one. This one is a 2n plus 1. Now if I multiply it out, I get 8n squared plus 4n plus 6n plus 10n plus 3. So that means n is equal to minus 3 over 4 when I set each to 0, or minus 1 over 2. They're just legwork. That was that one and that one. 15 and 16. Oh, good. 17. 8. I was just happy for a second there. 18, 19, 20. So, yeah, it's the same. Really want you to work these generally on a test. If your teacher's giving you a lot of, or on a review, if your teacher's giving you a lot of one thing. That one thing's going to be on the test a lot. Glad we got rid of the fractions, though. We're looking for a number that's going to multiply out to minus 180 and add up to minus 3. Since this number is very small and this number is very big, the factors are going to be close together. So like 18 and 10, close. Even closer. Factors of these that are, well, let's do it like this. 180 and 1, 90 and 2, 45 and 4. Divide this by 5, multiply this by 5. This is 9 and 20. No, we're going the wrong way now. We're going to get this a bit smaller and this a bit bigger. 10 and 18. Ah, I got to cheat again. Got to add up to 3. Ah, 15 and 12. Since they're both negative, and that's negative, one's going to be positive, one's going to be negative. The bigger number is going to be, the bigger of the two numbers is going to be negative because this is negative. Because minus 15 plus 12 is minus 3. Minus 15 times 12 is minus 180. Which means my factors, here I'll try grouping this time. For grouping, you take the first one and the last one, and the middle term you divide up into your two factors, minus 15x and plus 12x. Okay, and what do these have in common? They have 5 and x. You get 4x minus 3. What do these have in common? They've got 3. You get 4x minus 3. Notice the brackets are the same, so that's one factor, 4x minus 3. When you factor out those brackets, you're left with 5x plus 3. So these are the two factors. Which means x is minus 3 over 5 or 3 over 4. Boy, it's just hammering these, eh? 20 of them's a lot. Okay, this they've just put the 15 on the other side, but really just bring the 15 to the left side to make it equal to 0. And then they put the 30n squared in the wrong area. 30n squared minus 7n minus 15. 0. So this is the real equation that we're looking for. Which means we're looking for numbers. He's just making the numbers big. That's what he's doing. We're looking for numbers that multiply out to minus 40 and add up to minus 7. Again, very close. 45 and 10 is not close enough. 50 and 8, not close enough. Yeah, I'm so lazy with these. It's okay to use any tools for practice that you want. We're looking for numbers that are close together. That add up to, what's we're adding up to? 7, 18, and 25. There we go. Because the negative 7 is negative. It's going to be like that. Sure enough, 10 times 1, 8 times 1, yeah, that's multiplies out to minus 450 and adds up to minus 7. Slip and slide method, n minus 25, n plus 8. Take the number in front, which is 30. These are both divisible by 5. That becomes 5. And this becomes 6, and the 6 slides in front. So we get 6n minus 5. 8 and 30, they're both divisible by, 2, 4, and 15. Yeah, 15 slides in front. 15 plus 4. That's not correct. They're both divided by 2, 4. There's 18, not 18. That's 18 divided by 30. They're both divisible by 6. This becomes 3. This becomes 5. 5 slides in front. You get 5n plus 3. Let's make sure. 30n squared plus 18 minus 25 minus 7. Yeah, minus 15. So that is indeed our factors. When we set either one to 0, we can see that n is either 5 over 6 or minus 3 over 5. Okay, what's the trick for this one? We have to bring them all to the one side. It's always best to keep your y squared or your x squared positive. So those are my factors. I'm looking for them for the fact. So I'm going to factor out to 24 and add up to minus 10. So you're looking for 6 minus 6 and minus 4. They multiply out to plus 24 and add up to minus 10. 6 minus 4. By grouping, what's in common here? 2 and y. You get 4y minus 3. And the other one, what's in common with minus 4y and 3? Nothing, just the minus 1. 4y plus 3. Or sorry, minus 3. So you get 2y minus 1 and 4y minus 3. Yeah, it works. So that means my answer is 1 over 2 or 3 over 4. Okay, in this one, it's good to bring the 30m squared to the right side because it's negative there. So we're going to, sorry, to the left side. So we're going to add 30m squared to everything here. And now it's going to be equal to 0. And don't forget that there's essentially a positive in front of that. So we're looking for something that multiplies out to minus 120 and adds up to 19. 12 and 10, no. So not 12 and 10. 20 and 6, no. 6 is 14. This is 2. Make sure we got it right. Last 120 and adds up to 19. 12 and 10 does not work. 24 and 5. Yeah, 24 and 5. How I got from 12 and 10 to 24 and 5, if I half that, I have to double that. 24, 5. If this is a factor, 12 and 10, then half that and double that is a factor. And I can see that when this is positive and this is negative, they add up to 19 and multiply to minus 24. So positive 24 and negative 5. M plus 24, M minus 5. If I divide this by 30, they're both divisible by 6. This becomes 5 and this becomes 4. So you get 5 slides there. When I divide this by 30, they're both divisible by 5. This becomes minus 1. This becomes 6. 6 slides in front of m. So if I just test it, 30 squared minus 5 plus 20 is, nope. So again, I've done something wrong because I didn't use the factors that I figured out. 24 minus 19. Yeah, minus 19, that's the problem. Plus 24 minus 19. Divided by 30. They're both divisible by 6. I get 5 and 4. 5m plus 4. That looks right. This is the one that I screwed up. Yeah, minus 19. It's not they're both divisible. They're not divisible by anything. So it's become 30m minus, really? 30m minus 19? No. 6m. So they're not divisible by 5. I'm going to have to go back and do this again because I screwed something up here. So always good to start fresh because your brain can get stuck on something. It's got to out. It's got to add. Yeah, sorry. It's 24 and 5. Yeah, so it's 5. Sorry. And that's a negative 5. So m plus 24 when I divide it by the 30. They're both divisible by 6. This becomes 4. This becomes 5. So it's 5m plus 4. And this one, m minus 5, when I divide by 30, they're both divisible by 5. This becomes 6m minus 1. Let's make sure. Minus 5 plus 24. Yeah. And I got that right. Minus 4. I just did the math wrong. So solving for this is minus 4 over 5. Solving for this is 1 over 6. And finally, this last one. So all he's doing is he's making me put it all into the correct side. If I subtract these from the right side, I got 30k squared minus 7k minus 2. I need to find a factor that multiplies out to minus 60, adds up to minus 7. It's not 6 and 10. That would be 4. So is it 3 and 20? No. 3 and 20. That's closer than 3 and 20. 6 and 10 doesn't work. 5 and 12. Yeah. No. That's it. 5 and 12. So I'm talking about minus 12, positive 5. They multiply out to minus 60 and add up to 7. Slip inside k minus 12. If I divide it by 30, they're both divisible by 3. This becomes 4 and this becomes 10. No, they're both divisible by 6. So this becomes 5k minus 2. And then the other one, k plus 5, when I divide by 30, becomes 6k plus 1. I multiply this out, get there, plus 5k minus 12, that's minus 7, and then minus 2. Solving, this is 2 over 5, and this is minus 1 over 6. So there you go. That's that page.